For today is about sampling and sampling distribution. So specifically covered the random sampling. No? Some researches aim to study, describe, and infer patterns of behavior, properties, and characteristics about a population. Sometimes, they intend to study in a very large scale, and because of the fact that we cannot study a very large population due to feasibility, impracticality, and inconvenience, that is why we must select a representative sample from the population. In this discussion, sampling techniques that help researchers select samples that would represent true inferences about the population where these samples came from. Now, what is population? It is the group you want to generalize. So it consists of all the members of the group you are interested in. Sample is the subset from the population you want to examine. A population commonly contains too many individuals to study conveniently and practically, so an investigation is often restricted to one or more samples drawn from it. A well-chosen sample will contain most of the information about a particular population parameter, but the relation between the sample and the population must be such as to allow true inferences to be made about a population from the sample. Okay, so sampling is a process used in statistical analysis in which a predetermined number of observations are taken from a large population. There are various sampling methods that allows all the units in the population to have an equal chance of being selected. And the sampling methods are follows. So, in simple random sampling, each element of the population has an equal chance of being selected. There are no rules that dictate where and how you will start the selection process as long as you do not intentionally look for a specific number. In this method, the samples can be selected through lottery method. So every member is assigned a unique number, and these numbers are put in a jar and thoroughly mixed. After that, the researcher picks some numbers without looking at it, and those people are included in the study. Next, of course, is the use of table of random samplings. This table consists of a series of digits 0 to 9 that are generated randomly. The numbers are arranged in rows and columns and can be read in any direction. All the digits are equally probable. So, to determine the desired number of samples needed give a certain number of population, there are different formulas can be used, and one of which is the common or the Sloven's formula. So, we have here a Sloven formula. So, n is equal to uppercase n over uppercase n margin of error squared, no? So, as what we have here, lowercase n is a sample size. E as what we have here, no? No, this n, of course, is for sample size. This E, no, for margin of errors, squared, no, as you can see here. Then uppercase N is the population, that is the uppercase N, and of course the uppercase in here, which identify as population size. So, for example, so we have a given already here about, we have a given already, no? So, N is unknown, for example. So, that's what we have here. Then, margin of error is 0.05 or 5%. Then, number or population size is 1,000. For example, you have a 1,000 student and you want to find out how many, no, sample size possible to undertake to answer all your questions based on your research. So for us to get the sample size, what we're going to do is to apply the Sloven's formula, as I mentioned. So as what we have here, direct substitution, that is 1,000 because n, uppercase is n is 1,000 based on the given, that's what we have here. Then 1,000 multiplied by 0.05 because our margin of error is 0.05 squared. Then, of course, what we're going to do first is to multiply the squared 0.05 to square, that is 0.0025. Then, of course, 1,000 multiplied by 0.0025, that is 2.5. Then, n is equal to 1,000 over 2.5. So, the answer is, or the sample size is 400. So, instead of considering 1,000 participants of the study, using the Sloven's formula, we can get 400 as a sample size for your study. Now, we have also what we call systematic random sampling. This can be done by listing all the elements in the population and selecting every kth element in your population list. And this is equally precise as the simple random sampling. It is often used on long population lists to determine the interval to the use in identifying the samples to who will participate in the study. Use the formula K is equal to population divide sample size. Example. So, in population, n is equal to 2,000. Sample size, for example, is 500. So, K is equal to 2,000 over 500 is equal to 4. No? So, use a table of random numbers to determine the starting point of selecting every fourth subject. So, with list of the 2,000 subjects in the sampling frame, go to the starting point and select every fourth name on the list until the sample size is reached. Probably, we'll have to return to the beginning of the list to complete the selection of the sample. Because, for example, if you have a 2,000 population, targeted, then you wanted to have a sample size of 500. How will you get the 500? The 500 respondents or the 500 participants of your study on the available 2,000. So, what you're going to do, as what we have here, you may apply the systematic random sampling. Okay? So, for example, you just list the 1 to 2,000 name. Then, every count 1, 2, 3, 4, you get. 5, 6, 7, 8, get. 9, 10, 11, 12, get. Every fourth, based on the given formula. Another, of course, is the stratified random sampling. This can be done by first dividing the elements in the population into strata, and then samples are randomly selected from each stratum, ensuring that each selected element is proportionately represented in the total population. Sampling fraction, n or lowercase n divided by n. Desired sample size divided by the population size. So, for example, example again. Assume you have a population of 1,000 students with 500 from grade school, 300 from high school, and 200 from senior high school. Determine how many samples do you need, or you can use the Sloven's formula or any other formula for computing the sample size. In these examples, Sloven's formula is used and the sample size of 400 is computed. So to get the samples from each stratum, divide 400 by 1,000. And the answer is 0.4, right? So multiply 0.4 to each of the number of students per stratum. So for example, as what we have here, for grade school, we have 500 times 0.4, that is 200 sample size. It means to say that from grade school, you need to get at least 200. Then for junior high school, 300 divide 0.4. So you can get the 0.4, that is, of course, 120. 0.4, again, times 200, that is 80. 0.4, so therefore, 1,000, you can get 400 sample. Okay? So, in a stratified random sampling, of course, we can say that we can get equally a number of participants of the study based on the given stratum. So, equally distributed from the grade school, junior high, and senior high. So number 4 is the clustered sampling. A multi-stage sampling method adapted when it is either impossible or impractical to compile an exhaustive list of elements found in the stage in the target population. The whole population is subdivided into clusters or groups, and random samples are then collected from each group. Example, a researcher wants to survey about academic performance of high school students in the municipality of Batangas. He can divide the entire population into different clusters or barangays. Then, the researcher select a number of barangays depending on his research through simple or systematic random sampling. The researchers could draw random samples from the selected barangays through simple random sampling or take them all. More example actually, simple random sampling in a recent research that was conducted in a private school, the subject of the study were selected using the table of random sampling. The stratified sampling, a teacher who is conducting a research on the effects of using mobile phones in teaching mathematics decided to divide her student into male and female, and then she selected students from each gender group. For systematic sampling, the school office personnel gave the researcher a list of 2,000 grade 12 students. The researcher selected every 25th name on the list. For the cluster sampling, a researcher surveyed all COVID-19 patients in each of the 10 randomly selected hospitals in National Capital Region. Okay, now, lesson number 2 is about parameter and statistics. In this discussion, you learn about random sampling, a process done in selecting an unbiased representative sample from a population. This time, you will be introduced to the measures involved in the population and sample. Measures from a very large population are impossible to obtain, especially if your resources are limited. This brings us to other measures which are from the representative samples, and this discussion will help you identify measures about population and sample. A measure that describes a population is called parameter. A measure that describes a sample is called statistics. Okay? In population parameter, mean is represented by represent variance and represent standard deviation. In sample statistics, mean is represented by uh, represent variance and represent standard deviations. Data from a sample are used to calculate statistics. And statistics are estimates of the corresponding parameters. Now, example. For example, parameter is 50% of the 24 Philippine senators agreed to support a certain measure. A statistic, a researcher found out that 25% of the students in Philippines reported to have internet connection at home. The example indicates a parameter since there are only 24 senators in the Philippines, right? Researchers cannot ask millions of students if they have internet connection at home, so they take samples from the target population and calculate. Again, for example parameter, the example indicates a parameter since there are only 24 senators in the Philippines. Researchers cannot ask millions of students if they have internet connection at home, so they take samples from the target population and calculate. Parameter includes population mean, population variance, and population standard deviation. While statistics is a measure that describes a sample, statistics include sample mean, sample variance, and sample standard deviation. Now, we have here a sample distribution of the sample means. You learned in the previous lesson about discrete probability distribution and continuous probability distribution. In this topic, you will learn how to identify and construct sampling distribution of sample means. You also learn on how to find the mean and variance of the sampling distribution of the sample mean. So, if you list all the possible sample of size 3 drawn from a population of 4 with elements 2, 3, and 4, you will have 9 samples. The table shows the 9 samples and their corresponding mean. So, as what we have here. So, we have sample 2, 2, 2, 3, 2, 4, 3, 2, 2, 3, 3, 3, 4, 4, 2, 4, 3, 4, 4. That is 9. And the possible sample mean, that is 2, 2.5, and so on and so forth. Because 2, as what we discussed before, 2 plus 2 is 4. Divide 2, that is 2. 2 plus 3, 5. Divide 2, that is 2.5. 2 plus 4 is equal to 6. Divide 2 is equal to 3, and so on. Then, this let us learn how to make a probability distribution of the sample means. So, we shall call this distribution the sampling distribution of sample means. So, as what we have here, we have the sample mean here, and we have a frequency at this time, no? So, we have 2 as a sample mean, frequency is 1. So, therefore, the probability of mean is 1 over 9. This one, that is 2, 2 over 9. Since frequency is 3, 1 over 3. Then 2, that is 2 over 9. Then 1 is 1 over 9. So, how do we come up with this? No? Because 9 over 3 is equal to 3, right? So, therefore, 3 over 9, that is 1/3. Okay? So, because as you can see here, the 2 over 9. So, if we're going to do this one, that is 3 over 9, right? But 3 over 9, that is 1/3. So, instead of writing 3 over 9, that is 1/3. Okay? A sampling distribution of sample means is a probability distribution that describes the probability for each mean of all samples with the same sample size. Now, finding the mean and variance of the sampling distribution of sample means. The following are formula needed to complete the mean, variance is standard deviation of population, and mean variance is standard deviation of the sampling distribution of a sample means. So based on the given formula here for mean for population, mean for sampling distribution of sample means. This will be the formula for variance in population, and this will be the formula for sampling distribution of sample means. This will be the formula for standard deviation in a population, and this will be the formula for sampling distribution of sample means in getting the standard deviations. Okay. Sampling with replacement. So based on the given example, consider a population consisting of the values 2, 5, and 8. What we're going to do is to compute the population mean, compute the population variance, find the population standard deviation, and list all the possible samples of size 2 with replacement in their corresponding means. Find the mean of the sampling distribution of the sample mean, find the variance of the sampling distribution of sample means, and find the standard deviation of the sampling distribution of sample means. So, as what we have here, if we compute the population mean, we can get 5. Okay, based on the given formula, and of course, through direct substitution. Our summation, that is 2 plus 5 plus 8, based on the given. For us to get the population mean, right, over 3, because we have only 3 sample, okay, or 3 number of occurrence. So, if we are going to add this one, that is 15 over 3. So, therefore, our population mean is equal to 5. Compute the population variance. So, we have 2, 5, and 8. So, x minus population mean. So, 2 minus 5, okay, because our population mean is 5, no? 2 minus 5, that is negative 3. 5 minus 5, that is 0. And 8 minus 5, that is 3. Now, how about if we're going to get the x minus population mean? So, then is squared. So, for us to get, of course, what we're going to do is negative 3 is squared. Because this will be the result of this, no? X minus population variance, no? Is squared. So, if we're going to square negative 3, that is 9. Squared 0, that is 0. Squared 3, that is 9. So, summation of x minus population variance squared is equal to 18. Because x minus u squared is 18. 9. So, squared, that is 18. Right? So, here is the population mean in, no? So, we have 6, no? So, because in getting the standard deviation, no? So, we need to define first, no? So, find the population standard deviation. That is, this will be the formula. So, theta is equal square root of 6. Therefore, the standard deviation is 2.45. So, list all the possible samples of size 2 with replacement in their corresponding means. So, as what we have here, for example, no, we have 9, no, as 9 observations. Then, if we're going to get the mean of this given, that is 2, 2, that is 2, 2, because if we're going to add 2 plus 2, divide 2, that is 2. 2 plus 5 equals 7, divide 2, 3.5. 2.8, o 2 to 8, that is 10. 10 divided to 5, and so on and so forth. Now, find the mean of the sampling distribution. So, with this, we could able to get 45. The summation of mean is 45. Find the mean of the sampling distribution of means. So, based on the given formula, summation of mean over n. So, as what we have a while ago, we have 45, the summation of mean, over 9, because we have 9 observation. So 45 over 9, that is 5. So therefore, the sampling distribution of sample mean is equal to 5. Now, find the variance of the sampling distribution of means. Okay? So as what we have here, so we can get this, of course, same as what we did. So based on the given, we have 5, no? So 5 minus 2, 2 minus 5 rather, that is negative 3. 3.5 minus 5, that is 1.5. 5.5 minus 5 is 0. 5.5 minus 3.5. 3.5 minus 5, that is 1.5, and so on and so forth. Then for us to get this one, that is negative 3 times negative 3, that's 9. Negative 1.5 times negative 1.5, that is 2.925, and so on and so forth. Then, summation of mean, that is squared, that is 27. Find the variance of the sampling distribution of means. So direct substitution, then we could able to get the variance of the sample distribution is equal to 3 for sampling distribution of sample mean. Find the standard deviation. So direct substitution, that is 3. Square root of 3, that is 1.73. So therefore, the standard deviation of the sampling distribution of sample mean is 1.73. Okay, how about sampling without replacement? So consider a population consisting of the value 1, 3, and 5. So same as what we did a while ago, compute the population mean, variance, and standard deviation. Then, all possible samples of size n equals to 2 without replacement and their corresponding mean. Find the sampling distribution of sample means, variance of sampling distribution of sample means, and find the standard deviation of the sampling distribution of the sample means. Compute the population mean. So based on the given, we have 9. So 1 plus 3 plus 5, that is 9 over 3. So therefore, our population mean is equal to 3. Compute for the population variance based on the given formula earlier. So why 8? Because that is n minus 1, ano? Is n minus 1. No? Summation of x sub u, that's n. That is 8 over 3. So therefore, we had 2.67 as our population variance. Find the population standard deviation. So direct substitution. A while ago, we have 2.67. So square root of 2.67, that is 1.63. Therefore, the population standard deviation is 1.63. List all the possible samples of size 2 with the replacement and their corresponding mean. So same as what we did earlier, 1 plus 3, that is 4, divided 2, that is 2. That will be the sample corresponding mean. And so on. Find the mean of the sampling distribution of means. Okay, so as what we have here, we can get summation of mean is 18. Okay, because if we're going to add 2 plus 3 plus 2 plus 4 plus 3 plus 4, that is 18. And that is summation of mean. So how can we get this 2, 3, 2, 4, and of course, again, same. 1 plus 3, 4, divide 2, that is 2. 1 plus 5 is 6, divide 2 is 3. 5 plus 1 is equal to 6, divide 2 is equal to 3, and so on. Now, direct substitution for us to get the mean of sampling distribution of a sample mean. So, summation of x, that is 18, over 6, because we have 6 observation, as you can see here. So, therefore, our sampling distribution of sample mean is equal to 3. So, find the variance of the sampling distribution of the mean. So, same as what we did earlier. So, we can get this one, no? That is our given a while ago, that is 3, right? So, 2 minus 3, that is negative 1. 3 minus 3 is equal to 0. 3 minus 2, 2 minus 3, that is negative 1, and so on. Then, squared, again, Negative 1 multiplied by negative 1, that is 1, and so on. So therefore, if we're going to add 1 plus 1 plus 1 plus 1, that is 4. So therefore, our variance of sampling distribution is 4. Then, direct substitution for variance of sampling distribution of a sample mean. So based on the given formula, that is 4 over 6, or our variance of sampling distribution of sample mean is equal to 0.67. Okay, so for us to find the standard deviation of the sampling distribution, a while ago we can get the 0.67. So if we're going to get the square root of 0.67, we can get, of course, 0.82. This will be the standard deviation of the sampling distribution of sample means based on the given earlier. Now, the example above, by comparing the means and the variance of a population, the sampling distribution of the sample means, we can summarize the properties of the sampling distribution. We need to take note that if all possible sample of the size that can be drawn from the population of size n with mean invariance, then the sampling distribution of the sample means has the following properties. Of course, we have with replacement, wherein the mean of the sampling distribution of mean is equal to the mean of the population. The variance of the sampling distribution of means is equal to the population variance divided by the size of the samples. Then the standard deviation of the sampling distribution of mean is equal to the population standard deviation divided by the square root of the sample size of the samples. For without replacement, the mean of the sampling distribution of mean is equal to the mean of the population. The variance of the sampling distribution of mean is equal to the population variance divided by the size of the sample mean. And the standard deviation of the sampling distribution of means is equal to the population standard deviation divided by the square root of the sample size of the samples. So, to summarize the previous discussion, before we proceed to this one, the probability distribution of the sample mean is called the sampling distribution of sample means. A sampling distribution of sample mean is probability distribution that describe the probability for each mean of all samples with the same sample size. If all possible sample of size that can be drawn from the population of size n with mean of n variance, then the sampling distribution of the sample means has the following properties. And so on. Now, we may proceed to the sampling distribution of the sample means using the central limit theorem. The central limit theorem states that the sampling distribution of the mean approximate a normal distribution with the mean and a standard deviation of the sample size n of the random samples is large enough. Now, illustrating the central limit theorem, so given a die, it has 6 spaces in which each space has either dots x is equal to 1, 2, 3, 4, 5, and 6. Given it as the population, consider the sample size of n is equal to 1 and 2 if n is equal to 1. So, as what we have here, based on the given situation, that is, for us to get the mean, we are going to add 1, 2, 3, 4, 5, 6 over 6. Then we can get 3.5. So, note, computation for population mean in sampling distribution mean is the same for n is equal to 1. So, for us to get the variance, so we can get 2.92. Okay? Standard deviation. same scenario. So, given a die, it has 6 spaces again. Therefore, again, the computation of population mean that is 3.5. So, therefore, we can get 2.92 also. Now, so standard deviation. We have a sample 1 to 6. The mean is 1, 2, 3, 4, 5, and 6. Then the probability is 1 over 6. So, as what we have here, we have n is equal to 1. Then we have 0.18, 0.16, 14, 12, and so on and so forth. Now, how will be able to interpret the situation or scenario? The population mean in sample distribution means are both equal, which is 3.5. It has a variance of approximate 2.92 and a standard deviation of approximately 1.71. And since all samples have the same probability of 1 over 6 or 16 over 6, the trend of the histogram is like a flat line horizontally. So, as what we have here, if n is equal to 2, the population mean that is 3.5. The sampling distribution mean, same, that is 3.5. And our variance is 1.46. And to get the standard deviation, that is 52.5 over 36, that is 1.21. So the table shows a total of 36 samples and the probability of each are as follows. Then this will be the given central limit theorem graphs. Okay? So that's it. Thank you to our references. Belicena R. Bacay and Mateo E. Mercado J. Orones F. And a lot of URL, Investopedia, Lumen Learning, Quipper, math.uic.edu, libertex.org, and of course, the module from the Department of Education in our country, Philippines. Thank you and mabuhay everyone.